So I've been banging on to my boss about the need to really look after our early adopters. But we're selfish about that because we want to be there and observe how they use the tool. So the very first day that these guys shipped the Beta 0 product, I installed it with some help from my friends at a London-based charity. Now, when you say charity, most people think about, companies without much resources. This is a £12 billion medical research outfit based in central London. And they work with people like the Gates Foundation to fund medical research. As an organization, you could categorize them as a fairly sizable SME. They've got about 100 virtual hosts and about 1,000 servers, several thousand desktops of various types. And so and they're also a Neverfail customer for our existing products. So we went in there and said, look, we've got this fantastic, we think, tool. Would you like to try it out? Sure. What do you want to get out of this? So I talked to the enterprise architect, first of all. He said, well, we've got Landesk agents on all of our servers, and that allows us to automatically populate an inventory of stuff. And then what we do is we load that stuff into ServiceNow, and we manually draw the dependencies. And that is a very laborious, time-consuming process. And in fact, it's so laborious and time-consuming, it's a year out of date.
No one ever does it, yeah.
It's a year out of date.
So what we do it annually.
Yeah.
So what the enterprise architect, what I want to get out of this is I want to produce a report out of this thing that allows me to do a compare and contrast and see what's changed. And if we have confidence in that, then we're going to discard all this manual stuff, and now we're just going to produce the reports on demand. The DBA, he wants to use the circular dependency map. The first thing he wants to do with it is group together all the databases, and he wants to follow the traces to actually figure out if what he expects to see there as dependencies is actually the case. And if there's anything he doesn't know about, then he will see value out of the tool. And the guy that runs the operations team, the I&O guy, what he wants to do is get the protection assessments done. He also sees a lot of value in the tiering, because right now they haven't really sorted out relative priorities of workloads. So for them to go through the exercise of sitting down with a web-based tool with the sort of the heads of all the units of the grants people and whatever else, sit down and say, well, you've got these apps here. How important are they? How long could you be without them? How much data could you afford to lose? And by building up that map, he then gets a prioritized view, and he can then direct his spend on infrastructure with a bit more justification, a bit more argument as to why spend here and not so much over here. So he wants to know how good is the assessment right now and where are the holes, so I can fix them ahead of bad things happening. And then for planning future spend, I want to know where are the hotspots and where can I be less focused. So they're about 3 weeks in, and they're already getting what we hoped they would get out of it. And I think it's been a very positive kind of experience. And being in the business, Bob, you may guess who they are.
Yeah, that use case right there as an architect, using that justification for why we need to spend money, particularly with the business who says, oh, they always want tier one for everything for free. So if you can have, particularly when it's a third-party tool, it just provides a bit of external validation. Again, that's why we hire consultants for A, plausible deniability, but B, so that we can tell them the same things that people internally tell them, but they don't believe.
So, well, if I borrow your watch to tell you what time it is, you believe it. If you just look at your wrist, you don't.
Yeah,
sure.
So that helps to provide that justification. And
exactly.
I mean, one thing, I have no idea how you would build it in, but if you could go with that sort of historical view to show that this level of spend is required to achieve this level of protection.
Yeah, there is a feature on the roadmap which is sort of mildly contentious, right? Which is a phone home feature. So you can't deploy a virtual appliance and have it sneakily phone home. We don't do that, and we wouldn't do that. But we've built in the mechanisms to allow the user to turn it on if they so wish. And the rationale behind that is that in various vertical markets, people are obsessed with benchmarking how well they're doing vis-a-vis their peers. So the deal is going to be, this is what we're going to create as a use case, is to say, well, if you want to turn on the phone home feature, then based on your SIC code, we will then correlate in our database back at the ranch the stats from you, and then we'll give you on a regular basis a report back that says, here's how you're doing vis-a-vis your peer group in this SIC code.
If you could do it as an export and then air gap it over with a USB stick, certainly some customers would prefer that. Setting up some sort of export over the internet would be hard.
Actually, you know what? How the information gets propagated, I don't care. That's not the value. The value is once you've got it, can you then do that profiling SIC code by SIC code?
Yeah, and again, I mean, that's great for like IT managers and so on, because those are the guys who can justify that and say, we are at this level per industry, that's why I'm awesome and deserve a raise.
Yeah.
Yeah.
Yeah, yeah. So
I think in terms of timing, we wanted to use some offline time. I think we might be about there.
we wanted to talk a little bit about Engine, just a bit.
Okay.
Yeah, we have 15, 20 minutes at the end to get your off-camera feedback and answer off-camera questions.
So shall I talk about Engine for a bit?
Yeah, one thing I do want to mention briefly, I mentioned this earlier, but we are actually, we're in beta, and if you're interested in the beta, we are happy to obviously have beta participants, and I'm very happy to speak with you. Should I mention we'll make available after?
Oh, sure.
Yeah, so we'll do, once we have, right now we're in beta, so we obviously want to have a little bit more controlled process. But once we actually have an RC candidate for architect, and actually for the next release of the Heartbeat product, of course, we're branding, we will actually make available to folks here a license for the product, essentially, equivalent to that bar that will expire in a year. Things that we probably decided to do.
Yeah, we'd be really happy for your
We
feedback.
can't give you, we can't just hand out a beta product, even though we know you guys are really smart. We need to make sure we're there getting feedback. So we want to make sure people are in the beta program if they're really going to take the beta. But once we have RC soon, right guys?
Yep.
Okay. Very soon we'll be able to send you those.
Well, let's use the time that we've got remaining to suit your needs. I mean, what is the view of the audience? Do you want to hear a bit about the other product, Engine, the one that's been OEM'd by various people?
I don't know about these guys. I would like to.
Yeah, okay.
Is that the one inside a
Just one
vCenter
person.
Heartbeat?
Excuse me?
Is that the one inside a vCenter Heartbeat, or is it something else?
Is it, sorry, I'm a bit
Is
deaf.
that the product inside of vCenter Heartbeat?
Yes, it is.
Okay.
It is, exactly. So, shall we do that? We've got a...
That's over there.
I always say, where's the rubber? And then people go,
right.
what are you talking about?
That's hogwash.
Yeah, we were talking about that at lunch.
Well, that and the aluminum bag.
Aluminum.
Well, it was the piss, a piss.
Yeah, various language differences.
Alistair's hard to understand sometimes.
All right,
No,
so
it's not.
The slang is hard to understand.
just imagine for a second that you have a Windows machine. It could be physical, it could be virtual, we don't care. And it's running a SQL workload. And you want to make it continuously available. So you can take our product and deploy an agent that sits like that. That agent consumes about 3% to 5% of the CPU, and it takes about a 1 gig mem footprint. Okay, and it sits there. And if I then kind of explode what's inside this guy, one of the first things you'll find is a monitoring framework that looks a bit like this to begin with. So this is something called the AMF, Application Management Framework, and it provides a bunch of common services to things called plugins, which sit here. And in this example, where we're running SQL, you'll find what we call a system plugin and a SQL plugin. I think these are implemented as DLLs on Windows, right? That's what they are. And the purpose of these guys is to monitor the signature of the application running in what we assume to be a normal state. So the system plugin is looking at the resources that are being consumed by that workload. And because we've got a lot of experience of supporting the continuous availability of SQL, we know what sort of resource consumption profile SQL looks like when it's running in a normal state. So we've got our instruments running in the DLL, and we have some thresholds that we set, max, min, and when that thing is running fine, then everything sits within those max, min thresholds. As well as looking at resource consumption, the SQL plugin will do things like it'll run synthetic transactions from time to time. You can specify the interval so that it just makes sure that the database is responding. The whole purpose of this guy here is to send alerts if we see things beginning to go south, but before an outage actually occurs. That is the whole point of continuous availability, is to have so much application knowledge about failure signatures that if you see it going south, you don't just sit there and go, oh, maybe I should send an alert out. You can actually do something proactively to remediate that situation. The proactive thing you may do is go over to what I call SQL Prime over here, where we have exactly the same data sitting here as we have here, give or take a few seconds latency. Because what we're doing in this agent, as well as monitoring stuff, we're doing async replication across to this guy here, and we're dropping them into this data set over here. So part of the plugin's job is to know where in the file system a SQL database stores its persistent data, and also where in the registry system SQL is configured, so that we can pick up those configurations and drop them in over here. Now, if we begin to detect that something is happening here, we've got like a 3 strikes and you're out alerting system. So the first event can, for example, send a message to an operations console of some description and let operators know that something bad is about to happen. The second one, if we see, for example, that a SQL process has stopped, the second timeout can be configured to restart that service locally. And if that fails, the third one can then say, all right, switch over. So what do we mean by switch over? What we mean is, okay, we're going to block this guy from the network. This guy was blocked from the network. We're going to now reveal it. And we're going to start up the SQL services over here. And hey presto, everyone reconnects in real time. That's the way the system is designed to work. So I guess one of the concepts that's built into this, which I didn't explain earlier, is that if this has a server ID and an IP address, then this guy over here has the same server ID and the same IP address, and the reason we hide it during normal operation is so that we don't get conflicts. The reason we do it that way is that when you come to switch over, you hide this machine and you reveal this one, you've got absolutely 0 reconnect issues because this guy has the same identity. That's the whole point. It's to enable very fast switchover. So imagine you've switched over and you've sent an alert, and now you're running off this box here. At some point, you're going to want to switch back. So again, from the management console, you can tell the system to do a automatic resync so that all the updates that have happened over here are reseeding the database over here. And at some point, you're in steady state. And at that point, we quiesce the queues, flush the queues out, and then switch back over again. So one of the key use cases is completely automated failover, completely automated failback. That's a local HA scenario. Now, imagine that you've got a wide area network here. And across the wide area network, we've got SQL prime. Okay, so we've set this thing up for completely automated failover. So if the application management framework sees things going south, it spots a failure signature, and it goes, right, this system hasn't failed yet, but it's gonna, so I'm gonna automatically switch over here. If we have a different type of failure scenario, which is a site-level outage, then we can tell the system, which has been propagating the updates over here as well, manually to switch over. You could do it automatically, but nobody ever does. So there's a big red button. You can press the big red button, and the system will close down gracefully these systems and then fail over to here. It'll do that. It's been designed to do that within 2 minutes, RTO. And the RPO, 5 seconds max. So this is what we call a tertiary type setup. So this is your live system. We're replicating over here, but we're also pushing the updates over here. In this wide area network scenario, there's one other component that's quite cool, which is there's a dedupe engine, dedupe running here, and a dedupe running here. Dedupe, if I can spell. And unlike, like a riverbed type system, it's designed to work not in milliseconds, but in a matter of seconds, 1 second or so. Unlike a backup system, it's not going to take 10 minutes to dedupe. So what we're looking at particularly are data patterns that come out of things like SQL or Exchange, where we know there's going to be a string of data, both in the live stream, but also in the recovery logs, and we're going to look out for that and send a token across when we see that second string, as opposed to sending the data itself. So what we've seen from analyzing the deployments of our customers is we can get up to 70 to 80% reduction across the WAN by using that technology. And again, it's using the CPU cycles of this passive server here and this passive server here, so it doesn't impact the behavior of this guy here. Now, a lot of you will say, well, that's fine for SQL, but what about a complex 3-tier app? If you look at SharePoint, for example, then you're going to have SQL running, but you're also going to have some other things too. So imagine that this is no longer a physical box. Imagine this is a vSphere, or sorry, ESX system. And imagine it's got SQL on it. I mean, it wouldn't be set up this way, but imagine you've got SQL, you've got the SharePoint MOS stuff in the middle, and then you've got IIS as your web server. The next cool thing about the engine is that it allows you to create an arbitrary aggregation of workloads and treat that as a unit of failover, specifying what is the startup sequence when you fail that whole thing across. Now that is relevant for the site failover use case. It's not so relevant for local HA because we're assuming there's gig-E connecting these things. So actually, if you've got some things working here and some things failed over to here, it doesn't actually impact the performance of the system. But in the site recovery use case, it's very cool to be able to create these arbitrary aggregations. What do we call this thing? It's called the BAG, Business Application Grouping. And that's how you get a more complex 3-tier application to start up reliably on a site-level failover. So I've rambled on for long enough. You got any questions?
Yeah, what are the IP implications of that WAN failover?
Yeah, you've got to do, because here we're tricking it with this cloning approach. Here we have to update DNS, and that's what we do. We update DNS automatically.
What's in the use case of VMware Heartbeat, which is the ESX servers know the IP address they're being managed by, what's the impact in there?
Well, all this stuff I just told you. It's actually different for the OEM product because VMware asked us to create a multi-identity HA system, and we did that. So actually there's no trickery in terms of hiding and revealing the systems, but we have to do local DNS updates when we fail over, which is what we do automatically. Any other questions, folks?
How long have you been doing the dedupe? Because it's been a couple of years since I looked at this product.
We've been doing it, what was it, version 6? So
4 years, 5
4
years?
years. We're not, that's why we hired David to get some professional grade marketing in the business.
Yes, because one of the problems with the double takes of the world is when you run an application like that, you send all of your data twice.
Correct.
And so you double your WAN bandwidth. And so, log shipping, while it extends your RPO, vastly reduces your...
Totally. No, a lot of the OEM deals that I've done were done on the back of that one feature because people go, well, hey, in the real world, we want to get the most bangs for buck out of our WAN. We don't want to be flooding it with stuff.
Right. I just don't want to send database updates and then transaction log updates of the same
Totally.
data.
Totally. That's exactly it. All right. David, shall I?
There's a question on Twitter.
Oh, I got one more. Sorry, just to interrupt. So a mystery benefactor who cannot be named has helped us to port this whole kit and caboodle to Linux. It's now running in alpha. It'll be on Linux by the end of the year. Suzy Linux. Right, Kelvin? Suzy, right? Not Red Hat.
End of the year.
End of the year. That's what I said.
Any plans for Red Hat?
Well, we follow the money generally, so yeah, it's not off the table. But if
The
there's
mystery benefactor is a particular user of a particular distribution, then you
right,
follow the money.
we follow the money.
A particular distribution.
Pardon me?
Or the company that produces a particular distribution, I guess.
True.
Sorry, David, you said there was a question.
Yeah, there was a question on Twitter, just how does Heartbeat handle double physical parameters like MAC address or the MIDA? I'm not sure.
Double physical.
Yeah, and maybe someone more.
Yeah, so this is Hans' question, which I tweeted back to him about, but it's in that switchover, we've got the IP address that moves. So his question was around how do I handle the fact that you've got two different VMs, or there's another product, a physical machine and a virtual, and that IP address moves, what happens with MAC addresses,
So
that whole...
At the point of HA failover, the secondary, either the secondary or the primary machine issues a gratuitous ARP to fix up the IP address of the MAC so that you minimize, so there's no...
so there's no transit of a MAC across, the MACs stay on the physical NICs, it's the IP that transitions.
Correct.
Yeah, and they're independent objects, the VMs are independent objects, not like FT where you get two copies of the one VM.
No.
It's two independent VMs.
Correct.
Yeah, and actually, you probably heard me say that when we do the failover, we start up the services here, which is how we avoid that lockstep issue. If you've got a sick application, you've got another one over here. But it's not instantaneous failover. I mean, these are all trade-offs.
Unmodified application running inside the VM, there's going to be an outage for the failover.
Yeah. So one of the cool things about AMF, I mean, I could go on for ages, but I won't. But imagine here because we've now got our SharePoint thing going, we've got our IIS plugin, and this is true for any kind of web-facing app. Then the IIS plugin will run synthetic transactions to the website to see if the website responds. So again, it's this notion of if you put yourself in the user's shoes, you could be talking to a system that is alive and running, but if it responds in 30 seconds, you're not going to use it, right? It's, to all intents and purposes, dead. So being able to measure the health from that standpoint is what differentiates this technology, if that makes sense. Okay, Ringmaster, what do you want?
Any other questions?
Shall we go to the next phase?
Yeah, so the next phase.
Thanks for listening.
Yeah, thank you, everybody.